guys, in this video lesson, we will be discussing the probability of independent and dependent events. This is in lesson 12.5 in your book, if following a book helps you. So we know two events are independent if the occurrence of one event doesn't impact the occurrence of another event. So if we want to find the probability of two independent events, the probability of rolling a heads and then another heads, that would just be the probability of the first, 1/2, times the probability of a second, 1/2. So let's say I roll two standard 6-sided number cubes. A long way of just saying I roll 2 dice. What's the probability that you roll doubles and then a 10? So you could get doubles with a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4, a 5 and a 5, or a 6 and a 6. So there's 6 out of the 36 possible combinations. And then a 10. When they say a 10, they mean a sum of 10. So there's 3 different ways that could happen. It's kind of nice with these large denominators to reduce. So the probability is 1 out of 72. Very low odds. What's the probability that you roll a sum of 8 and then double? So the odds of rolling a sum of 8 is 5 out of 36. And the odds of rolling doubles we just found was 6 out of 36. Not a great way to reduce that first fraction. But when we multiply this out, we get 5 out of 216, which is about 2.3%. Very low odds. What's the probability that you roll an even sum and then a sum greater than 8? Well, odds of getting an even sum are 18 out of 36. And the odds of getting a sum greater than 8 is 10 out of 36. Reduce both of those. Which gives us 5 out of 36, which is about 13.9%. Example 2. The probability of selecting a rotten apple from a basket is 12%. I think that seems a little high, but that's the odds in this scenario. If you select one from each of the 3 different baskets, what is the probability of selecting 3 good apples? So the probability of getting a good apple is 88%. And the odds in each basket is 88%. And because I'm selecting from one from each different basket, those events are independent. So about 68.1%. What are the odds of selecting 2 good apples and then a rotten apple? Well, the odds of getting a good apple in the first basket is 88%. The second basket is 88%. The third basket, if I select a rotten, the odds is 12%. And if I multiply all that out, I get about 0.0093, about 9.3%. What are the odds I get 3 rotten apples? Hopefully this is low. So the odds in the first basket's 12%, second basket's 12%, third basket is 12%. So we're talking about 0.001, or we could round up to 2. Third example. A game machine claims that 1 in every 15 people win. What is the probability that you win twice in a row? Well, you walk up there, the odds of winning is 1 in 15. If that probability is consistent, then that means it's independent. So no matter if I win or lose in that first, the odds that I win that second time is 1 out of 15, which is 1 out of 15 squared, 225, about 0.4%. Very, very low odds. Example 4. In a survey, 9 out of 11 men and 4 out of 7 women said that they were satisfied with the product. If the next 3 customers are 2 women and a man, what is the probability that they will all be satisfied? So the odds that that first woman is satisfied is 4/7. The second woman is 4/7. And that man is 9/11. So this comes out to 144 out of 539. Divide that out, you get about 0.26, about 26.7%. So 2 events, conversely, are dependent if the occurrence of one affects the occurrence of the other. So the probability that B will occur given that A has already occurred is called a conditional probability. It's based on some condition and is written probability of B based on A. So if A and B are dependent events, the probability that A and B both occur is still the probability of the first times the probability of the second. It's just that the second probability is conditional, so it was based on whatever happened to begin with. So let's say we walk up to a gumball machine. It's got 100 gumballs in it, 20 of each of these 5 colors. So let's think about the probability of getting 2 reds. Well, the probability of getting a red to start is 20 out of 100. But if you already took 1 gumball out of the machine, you're down to 99 of them, and only 19 of those are red. So that gets you 380 out of 9,990. Came out wrong, sorry. 380 out of 9,900, which is about 3.8%. Let's talk about blue. So the odds of getting a blue are 20 out of 100. And then white. Well, there's still 20 white gumballs because we took a blue, but now there's only 99 gumballs. 4%. Odds of a blue and then a blue and then another blue. Well, if you're thinking about this, the odds of a blue are 20 out of 100. But you've taken a blue gumball. So now you only have 19 blue gumballs out of 99 in the machine. And now you only have 18 blue gumballs out of the 98 in the machine. So it comes out to about 0.007. A green, then a red, then a blue. So the odds of getting a green are 20 out of 100. The odds of getting a red, there's still 20 reds, but there's only 99 gumballs. And now there's 20 blue, but there's only 98 gumballs. So we come out to about 0.008. A yellow, then a yellow. So this is going to look just like at the top when we did 2 reds, because the odds of getting a yellow are 20 out of 100. And then a second yellow is only 19 out of 99. Same as part A. So in this problem, we're going to be using a deck of cards. Again, I gave you that diagram on the reference sheet. I think it's also in your textbook. But if you don't know cards well, you might want to refer to it. So you randomly select 2 cards from a standard deck. So a standard deck does not include jokers, so it's 52 cards. Find the probability that the first card is a diamond and that the second card is red if you replace the first card for selecting a second. So the odds of getting a diamond are 13 out of 52. There's 13 cards in each suit. Card back, so now there's still 52 cards. Then the odds of getting a red, well, half the cards are red and half the cards are black, so 26 out of 52. Now in this part B, I know this is part A, but in this part B, It's the same problem, but if we don't replace that first card, well then, there's only 51 cards. And not only that, diamonds are red, which means we no longer have 13 to pick for, we have 12 to pick for. This comes out to about 0.059. Example 7. You and 2 friends go to a restaurant and you order a sandwich. The menu has 10 types of sandwiches, and each of you is equally likely to order any type. You're not sold on something. No one's a vegetarian. No one has to have meat. Everything's equally likely. So to start, we have 10 out of 10. But once I order a sandwich, you only have, or once you, I should say, order a sandwich, your friend only has 9 options. And once you and one of your friends pick, then that last friend only has 8 options. So it comes out to 0.7. These last 2 examples we are going to save until next week when we talk about permutations and combinations. Tom saves that for last. Your book throws that in a little earlier. I hope this lesson helped. There are some topics in this week's lesson that are a little more advanced, so you may want to watch 1 or 2 of the cons at the very end.